In this video, I'll be explaining question 2 of homework 10. So we need to collect the definition of the properties of stochastic processes, and we need to explain about these. So the first part is wide sense stationary process. So a wide sense stationary process is when it has a mean which is constant, and the autocorrelation depends on the time difference t1 minus t2 or t2 minus t1. So r t1 t2 represents the average power of the signal t1, and when the input in a wide sense stationary process when the input is a wide sense stationary process, then the output of a stable LTI system is also WSS. So yeah, that is a wide sense stationary process. Now moving on to independent increment process. So what it means is that xt1 minus xt2 and xt3 minus xt4 on the non-overlapping intervals are independent, and the process like Poisson process, random walk, and Wiener process, which we discussed in question 1, these are independent increment process, and they follow the Markov property. Now the third process that we need to define is the Markov process. So according to the Markov process, if we are given a present value, then the future will be independent of the past value. That is, future is independent of the past given the present value. So mathematically we can say that probability of xn equals to xn given xn minus 1 equals to xn minus 1, xn minus 2 equals to xn minus 2 up till x naught equals to x naught will be equal to the probability of xn equals to xn given xn minus 1 equals to xn minus 1. So here the present value is xn minus 1, the future value that we are trying to calculate is xn, and all the past values, we can say that since it is a Markov process, it will be independent of all the past values. So that is what a Markov process is. Next, moving on to the normal process. A normal process is when the random variables xt1, t2 up till xtn are jointly normal, and that is true for any value of n and any value of t1, t2 up till tn. So we can further say mathematically that fx of x1, x2 up till xn, t1, t2, t3 up till tn is given by 1 upon 2 pi to the power 1 by n times e raised to power 1 by 2 x minus mu transpose c inverse x minus mu, where c and divide by under root of determinant of c. So here c is the expectation of x minus mu times x minus mu transpose, and x is basically a vector x1 to xn, and mu is the mean or expectation of x. Moving on to the fifth process, which is strict sense stationary. So a process is a strict sense stationary process when its statistic is not affected by shift on the time axis. So that means that if we shift the process by some epsilon value, then even then the distribution will remain same. So fx of x1, x2 till xn t1 t2 up till tn is equal to fx of x1 x2 up till xn t1 plus epsilon t2 plus epsilon tn plus epsilon. So we are shifting the time axis by epsilon. So that is SSS. Now we move on to white noise. So a stochastic process is a white noise if the expectation of the process is 0 and the autocorrelation is of the form qt1 impulse of t1 minus t2. So for the Wiener process that we saw in the previous question 1, uh, if we take the derivative vt equals to dwt by dt, that is what is a white noise, and here wt is continuous with probability 1. So the expectation will be 0, and if we calculate the covariance autocorrelation, then that will be alpha times impulse of t1 minus t2. Yeah, for mean ergodic process, so yeah, it has this property that the limit of 1 by 2t minus t to t xt dt, where xt is the mean is the process which we are talking about, and t tends to infinity. Now this value, if it equals to the expectation of xt, then xt will be a mean ergodic process, and this should happen it should be equal to expectation in mean square sense. And so this is one property of mean ergodic process. And next we have martingale. So martingale is when so it is kind of a sequence of random variable or a stochastic process for which at a particular time the conditional expectation of the uh, past value in the sequence is equal to the uh, present value regardless of all the prior values. And mathematically it is given as expectation of xt given xs uh, is equal to x1 is equal to x1 is x1 for s less than equal to t. Yeah, so this was the last part of question 2.